Okay, so today we're going to talk about radical expressions continued, and we're going to expand our radical operation from square root to other operations. Definition number 1. Let's check out this definition, which is right here. Last time we talked about square root. So if I have a square root of a, it is the same as a to the 1 over 2. And how do you see that is you check out the exponent inside. Right here, I have a, which is the same as a to the first power. And then we have a square root as the radical operation. For the square root, we don't have an index displayed, but there is a hidden 2 right there. And as you can see, all you need to do is using the exponent inside, which is 1, divided by the index outside. And that's how you get 1 over 2. And you could expand this to any index. For example, I could expand it to cube root of a, right? So this will be a to the 1 over 3. Fourth root of a, this will be a to the 1 over 4. And you can even do 100th root of a, and this will be a to the 1 over 100. So this is the definition number 1. Let's start with example 1. Example 1 says you're going to write with a rational exponent. Rational means fractions. So we're writing something like this. You have a base, and then you have a fractional exponent. So let's start with number 1. Number 1 is square root of 11. So we know that the exponent inside is 1 because it's 11 to the first power. And the index, it's a square root, so the index is 2. As a result, you simply keep the base 11, and then you write 1 over 2. Let's also do the practice side. So practice side is square root of 30. We keep the base, and as you can see, the exponent inside is 1, and the index is 2. We have 30 raised to the power of 1 over 2. Moving on to number 2. Number 2 on the left-hand side, we have cube root of 11. So it's the same thing. Analyze the exponent inside, which is 1, and the index outside is 3. So we keep the base 11, and then we write exponent divided by index. 11 to the power of 1 over 3. And then on the right-hand side, we have fifth root of 30. So same thing, the exponent inside is 1, our base is 30, and if you write it, it's going to be 30 to the power of 1 over 5. Okay, number 3. Number 3, instead of having a number inside, we have an algebraic expression, which is 5 times y. So if this is the case, your radicand has more than one factor, and you want to rewrite this with a rational exponent, you will need to use parentheses. And then inside, you're going to put the radicand inside. So in this case, it will be 5y. So we're treating everything inside as a base. And then if I put the exponents back, so everything inside is raised to the first power. And then the index, because it's a square root, it's 2. And as a result, we have the base 5y with parentheses and raised to the exponent of 1 over 2. And then let's use number 3 on the right-hand side as a practice. Same thing, right? The base will be parentheses, the inside of the square root, and that's 10m. And then if I put the exponent back, the inside is 10m raised to the first power, and the index is 2. So our exponent for the 10m will be 1 over 2. Okay, example 2. Simplify the following. So example 2, as you can see, all of these expressions are exponents with a rational exponent, meaning that our exponents are fractions. And you could do this if you want, or you could convert it to the radical form, which is probably better in my opinion, because it's easier to see what you're doing. So what you do is you first identify the base. Our base is 8, So this is the radicand. It's the number that goes inside the radical sign. And then you could do a radical sign because we know that it's going to be radical by the fraction. We have a fractional exponent. That's how you know that you have a radical. And then your numerator, which is 1 right here, goes inside. That's the numerator. And the denominator, in this case, is 3. It goes outside. So you could put a little note right here, right? So numerator is inside, okay? And then denominator is outside. Something that you can kind of refer to when you do these kind of problems. Let's do one more example. Practice 2, number 1. So first, identify the base, which is 27, right? And then we're going to look at the radical sign. The numerator is 1, so it goes inside. And then the denominator is 3, it goes outside. So that's how you convert from a rational exponent to the radical form. But that's not the end of it because the question talks about simplifying. So we still need to simplify. Now we have the radical form. We need to go back and simplify it. Let's rewrite this. This is basically the cube root of 8, right? Cube root means that you have a number such that when you raise to the third power, you get the radicand, the number inside. You could use your calculator, or you could think about which number raised to the third power will be 8. The number is 2. Because 2 to the third is 8. Same thing on the right-hand side. Cube root of 27 is 3. This is because 3 to the third power is 27. Okay, moving on to number 2. Number 2, we have x to the power of 1 over 2. And if we convert it to the radical form, we have our base, x. And then we have a radical sign. And then numerator is 1. Denominator, 2. So this is essentially square root of x. Because we don't know what x is, this will be our final form. We cannot simplify further. On the right-hand side, it's a negative x raised to the power of 1 over 2. Because we don't have parentheses, right? As you can see, there's no parentheses like this. The negative sign is not part of the base. So you're going to leave it alone, write the negative sign. And then we're going to do what we did on the left-hand side. You have your base, which is x, and then you have your radical sign. And then the exponent numerator is 1. Denominator is 2. So this simplifies to negative square root of x. Number 3. Number 3, this is y to the 1 over 3. So you write the base, y, and then you do the radical sign. The numerator is 1, so it goes inside. Denominator 3 goes outside. And this simplifies to cube root of y. Since we don't know what y is, this will be the simplest form. Practice 2, number 3, z to the 1 over 4. So start with the base, z, and then radical sign. Numerator is 1, goes inside. Denominator is 4, goes outside. And this will be 4th root of z. Because we don't know what z is, this will be the most simplified form. Okay, example 3, simplify the following. So it's the same procedure. I'm going to start with the base. This time we do have parentheses. That means negative 256 is the radicand. And then you put the radical sign. And then the numerator is 1. So this whole thing is raised to the first power. I'm just going to keep it like this, right? Or actually, let's put it there. So exponent, numerator goes inside. And the denominator is 4, it goes outside. And this, if you simplify it, it's going to be 4th root of negative 256. This is similar to square root because your index is even, and that means the radicand cannot be negative. If it's negative, this is not a real number. So we simply say not real for now. All right, let's check out practice 3, number 1. We have parentheses, so that means negative 16 is the radicand. And then we have the radical sign. Numerator is 1. And then denominator is 4. And this simplifies to 4th root of negative 16. And because the radicand is negative, you say the same thing. This is not real. This is not real. Number 2, negative 256 to the power of 1 over 4. This looks very similar to number 1 with the difference that it doesn't have parentheses. So we know that the negative sign is by itself. So you're going to leave it alone. Just write negative sign. And then the base is 256. So I'm going to do 256 with the radical sign. This number goes inside. Next, identify the numerator, which is 1. It goes inside. Denominator is 4. It goes outside. So this will be what the expression looks like. It simplifies to negative 4th root of 256. You could use your calculator for this, or you could use a tree diagram. So I'm going to assume you don't have a calculator. Let's use a tree diagram. I'm going to do 256. It's an even number, so you could divide it by 2. So I divide it by 2, I will get 128. 2 is a prime number. I'm going to circle it. 128 is also an even number, so I'm going to divide it by 2. It gives me 64. Circle 2. And then 64 is an even number. I could do 2 and 32. Circle 2. 32 is even number. 2 and 16. Circle 2. 16 is also an even number, so 2 and 8. Circle 2. 8 is 2 and 4. Circle 2. And then 4 is 2 and 2. So as you can see, it's just factors of 2, which you probably remembered, because this is like the most electronic devices capacity, like 256 gigabyte. So it's base 2. And let's rewrite this. It's actually, let's change the color. It's negative 4th root of 2 to the, and then let's count how many 2's are there, right? 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 2's. 2 to the 8th. And then how do you simplify this? We will, since the exponent is 8 inside and the index is 4 outside, you will copy the negative sign, write the base, and simply divide the exponent inside by the index outside. It's very similar to what we did last time in terms of the square root. If it's an even exponent, you might remember we divided by 2. And now we have a 4th root, so you simply divide it by 4. And this will give us negative 2 to the 2th power, which is equivalent to negative 4. And you might wonder, why is this not positive 4? Aren't we squaring this? This is because this negative sign is by itself. When you square just the 2. So this is what you're looking at. And that's why you leave the negative sign alone. And then you get your answer, which is negative 4. Okay, now I'd like you to pause this video and practice with practice 3, number 2. Okay, practice 3, number 2. Let's guide you through. You're going to leave the negative sign alone, right? Because this is not part of the base. And then our base is just 16. I'm going to do the radical sign. The numerator is 1, so it's right here. It goes inside. Denominator is 4, goes outside. And this is the same as negative 4th root of 16. And for 16, we could do the same thing, right? Do a tree diagram. 2 and 8, circle 2. And then 2 and 4, circle 2. 2 and 2, circle both. So your 16 is 2 to the 4th. This becomes negative 4th root of 2 to the 4th. We have 4 2's. And then we do the same thing, negative 2 to the 4 divided by 4, which is negative 2 to the 1st, and that's the same as negative 2. So your final answer is simply negative 2 right here. Okay, number 3. Number 3, this time you do have parentheses, and the exponent is negative. So I will deal with the negative first. As you can see, we have this negative right here. If you remember, for negative exponents, we have a property, right? A to the negative, let's say, n, is equivalent to 1 over a to the nth. This is one of the exponential properties that we discussed before. I'm going to use this property and apply it right here. That basically means we have 1 over and then 256 to the power of 1 over 4. And then notice that this 256 to the power of 1 over 4 is the same as 4th root of 256. We did this earlier right here. We did this earlier right here. So we already know this is 4, right? This is 4. So we already know that the 256, if you take the 4th root, it's simply 2 to the 8th taking a 4th root. So we use the same tree diagram that we did before for 256. Replace 256 with 2 to the 8th. And this simplifies to 1 over 2 to the 8 over 4, right? Because you divide the exponent inside by the index outside. And that simplifies to 1 over 2 squared, which is the same as 1 over 4. And that's the final answer. Let's do the practice side together. It's 16 raised to the power of negative 1 over 4. So same thing, we're going to deal with the negative sign first. Write it as 1 over 16 raised to the power of 1 over 4. And then we could use the same tree diagram to rewrite this. So this is 4th root of 16, which is the same as 4th root of 2 to the 4th. And that simplifies to 1 over 2 to the 4 divided by 4. So remember, you're using the exponent inside divided by the index outside. And that's equivalent to 1 over 2 to the 1st, which is the same as 1 over 2. Okay, so that's the first page where you simply divide the exponent inside by the index outside. And the second page, it's definition number 2. And now we apply this to other exponents inside. We actually did this earlier. We did it like right here. We divided a by 4. We also did it right here, a divided by 4. We did it here, 4 divided by 4, 4 divided by 4. So we can generalize this result using definition number 2. Let's check out this definition, right? So it's basically saying that if you have an exponent with a rational exponent, you have m over n. The same kind of conclusion applies. Your actually, I'm going to use the second definition right here. So right here is what we concluded earlier, right? The numerator goes inside. So numerator goes inside. And then denominator goes outside. So that's basically what we have. And in the second one that I highlighted, and there's also this one right here. You could also rewrite the rational exponent using nth root of a raised to the nth power. It's also equivalent. Let's look at some examples. Example 4, write with the rational exponent. First, identify the base, right? The base inside is x. And then we know that the exponent inside is the numerator, so that's 5. And then over the index is the denominator, which is 2 right here, because it's a square root. So you put 2 in the denominator. We have x to the power of 5 over 2. Let's do the practice side. Our base is a. The exponent inside is 2, so that's the numerator. Index is 5, so that's the denominator. A to the 2 over 5. Number 2. The base is whatever's inside the radical sign as the base. So in this case, it's 3y. This one you will use the first definition right here that I have it right here. So in this case, your base will be 3y. And then the 4 is the index, so that will be the denominator. And then you have the exponent, that's the numerator, so it goes to the top. On the practice side, we have 5ab, that's inside, so that's your base. The index is 3, so that's the denominator. And then your exponent is 5, that's the numerator. Number 3, on the left-hand side, the base is 2m over 3n. And the index is 2. It's a square root, so I could put a 2 right here. And that's your denominator. Your exponent is 5, so that's your numerator. Practice side, base 7xy over z. Index is 2. That's your denominator. And then exponent is 3. That's the numerator. And that will be example 4 and practice 4. Example 5. Now we're going to simplify this using the rational exponents. The first one is 27 raised to the power of 2 over 3. So I'm going to convert it to the radical form like what we did before. Base is 27. It goes inside the radical sign. And then the denominator is 3. So that's the index, which goes outside. The exponent is 2. And you could go inside, or you could just erase the whole thing to the second power. So I'm going to modify our definition here a little bit. The numerator, right, it could go inside, or you could go the overall exponents. And then for the denominator, it is outside, but it is referring to the index of the radical sign. Okay, the index of the radical sign. So you have two ways to rewrite this 27 raised to the power of 2 over 3. One way is what I showed right here, where 3 is the index and then 2 is the overall exponents. But you could also do 27, and then you have 3 as the index and then 2 as the exponent inside. And as you can see, this exponent, it could go inside or it could go all the way to the outside, raising the whole thing to an exponent. But in general, if you want to make it simple for you, you just need to remember whatever's in the denominator, that's the radical operation. That's the radical operation, which is going to the top left. And then the other one could go either inside of the radical sign, or you could raise the whole thing to that exponent. So the m could be right here, or raise the whole thing to the nth power. Let's keep working on this. It's cube root of 27 raised to the second power. So I'm going to follow the order of operations. We have parentheses. That means we're going to do cube root of 27 first. We did that before. It's 3. And then we're going to raise this 3 to the second power, which is 9. And now let's do one more example. It's 4 to the 3 over 2. So same thing. Base is 4. That means it goes inside the radical sign. Denominator is 2. So that means it's a square root. And then we have a 3. So I'm going to raise this whole thing to the third power. And this will give me 2 to the third because square root of 4 is 2. And that's 8. Moving on to the next one. Next one, we have a negative exponent. So I'm going to use the negative exponent property. 1 over a to the n to simplify this. So this is the same as 1 over 81 to the power of 3 over 2. And then we're going to use the same strategy. 1 over 81 is the radicand. And denominator is 2, so it's a square root. And then the whole thing raised to the third power. Let's keep simplifying. Square root of 81 is 9. And then we need to raise this to the third power. And that will give us 1 over 729. You could use the calculator for 9 to the third power. Okay, practice side. Practice side, we have 27 as the base. And the exponent is negative 2 over 3. Because it's negative, I'm going to do the reciprocal. So 1 over 27 raised to the power of 2 over 3. And then keep copying the numerator 1. We're going to write 27 as the radicand. The denominator is 3, so that's the index. It goes to the top left. And then numerator is 2, so I'm going to raise the whole thing to the second power. This simplifies to cube root of 27, we know that's 3. And then we raise it to the second power. So it's a 1 over 3 squared, which it is equivalent to 1 over 9. Okay, number 3. Number 3, we have another negative exponent. So I'm going to do 1 over 16 raised to the power of 3 over 4. And then I'm going to convert the denominator to the radical form. 16 goes inside. The index is the denominator, which is 4. And then raise this whole thing to the third power, which is the numerator. And then fourth root of 16, we did it on the first page right here. If you don't remember, we did it right here. It evaluates to just 2. So I'm going to just do 2 right here. It's 1 over 2 cubed. And that's equivalent to 1 over 8. The practice side, 625 raised to the power of negative 3 over 4. Same thing, we're going to do reciprocal first. It's 1 over 625 raised to the power of 3 over 4. And then convert the denominator to its radical form. 625 goes inside. Index is the denominator 4. And then raise the whole thing to the third power. And this time, I think we do need to do a little bit calculation right here in terms of the 625. If you know 625 is actually a fourth power. So 625 ends with 5. I could divide it by 5, which will give me 125. 5 is a prime number, so I'm going to circle it. And then 125 ends with 5, which means it's also divisible by 5. And it's going to give me 25 as the other number. 5 is a prime number, circle that. And then 25 is 5 times 5. Circle both. As a result, 625 is equivalent to 5 to the 5th power. So I have fourth root of 5 to the 4th power, and then you raise to the 3rd power. And this is equivalent to 4th root of 5. So basically you do 5 over 4 divided by 4. That's simply 5. And then we raise to the 3rd power. And that equivalents to 1 over 125. Okay, example 6. Example 6, we have a lot of negative signs, and these three expressions look all very similar, so you have to be very careful. Let's start with number 1. The number 1 negative sign is not part of the base because there's no parentheses, so I'm going to copy it, and then I'm going to convert this part right here, to the radical form. Base is 16, so it goes inside the radical sign. And then denominator is 2, so we know that it's a square root. And then raise the whole thing to the 3rd power. We know that the square root of 16 is 4, so this is the same as negative 4 cubed. And then evaluate that, it's negative 64. Next one is negative 16 raised to the power of negative 3 over 2. Since we have negative exponents, we're going to do the reciprocal first. But before you do that, you have to be careful. This negative sign is not part of the base, so you simply copy it. And then you do the reciprocal, okay? So we have 1 over 16 raised to the power of 3 over 2. And now let's convert the denominator to the radical form. So we have 16 goes inside the radical sign. Denominator is 2, so we know it's a square root. And then we raise the whole thing to the numerator, which is 3. And we did this before, right? We did this in the previous one, which is this piece right here. We did that. So this piece gives you negative 4. This piece gives you positive 64. So we will just simply copy this. It's negative 1 over 64. All right, number 3. Number 3, same thing. We have a negative exponent, but this time we do have parentheses, which means we will take the reciprocal of the whole thing. So it's 1 over 16 raised to the power of 3 over 2. Negative 16. Let's redo this. So we will treat negative 16 as the base. It's 1 over parentheses negative 16 raised to the power of 3 over 2. And then we're going to convert the denominator to its radical form. Just keep in mind that our base is negative 16, so it goes inside the radical sign. Denominator is 2, so we know it's a square root. And the whole thing is raised to the 3rd power. And notice that we have a square root, but the number inside is negative. It basically says that this is not real. It's not a real number. And you could just say not real. All right, I'd like you to practice with practice 6. It's very similar, as you can see. The only thing that's different is just the base. And you do need to simplify, so I'm going to give you the solutions, and hopefully you can get them. Okay, so these are the solutions to practice 6. Make sure you do practice. Moving on to example 7. Example 7, we'll use the exponential property. So which exponential property? Starting with number 1, we have 2 exponents multiplying with the same base, right? So the exponential property, you might remember, it's simply adding the exponents. So this will be the property that we use. Let's apply that. We have base x, and then we're going to add these 2 fractions, which is 1 over 6 and 4 over 3. So let's do the fraction calculation somewhere else. 1 over 6 plus 4 over 3. First, find the LCD. The LCD in this case will be 6. So I'm going to multiply the second fraction up and down, top and bottom by 2. And this will give me 1 over 6 plus a over 6. And that is the same as 9 over 6. Or you could divide both of them by 3, 3 over 2. So that's actually the final result, x to the power of 3 over 2. And you could just leave it like this, or you could convert it to the radical form. The radical form is simply, denominator is the index, so it's just the square root. And then numerator is the exponents. You could also do this. It's the square root of x cubed. And then number 2 will require you to use the next exponential property. If you have an exponent raised to another exponent, you will distribute or multiply the exponents. Let's use this one to demonstrate. We have x to the 6 raised to the power 4 over 3. So we need to multiply these two exponents. It's x to the 6 times 4 over 3. And let's do this calculation somewhere else, right? So 6 times 4 over 3 equals, I can convert 6 to 6 over 1 times 4 over 3. And I can factor 6 into 3 times 2. And then multiply by 4 over 3. And notice that there's a common factor of 3. So I can cross these two 3's out. And then multiply the rest. So it's just 2 times 4, which is 8, over 1. And that is 8. So our final answer is simply x to the 8th. Let's move this somewhere else because I need the space later. Okay. And then number 3. Number 3 will require you to use the property where you divide two exponents with the same base. We subtract the exponents. So in this case, we simply keep the base, subtract 2 over 3 by 5 over 3. And this will give you, so if you subtract the fractions, let's do it somewhere else. 2 over 3, right? Subtract 5 over 3. And this will give you negative 3 over 3, which is the same as negative 1. So we get x to the negative 1. And because we don't write negative exponents, we're going to use the negative exponential property. It's 1 over x. And that's the final answer. So let's highlight the final answer in this problem. Makes it a little bit easier for you to see. Those 3 are the final solutions. All right, I'd like you to use practice 7 as a practice. And then after you finish them, check your solutions, see if they're right. Okay, so these are the 3 solutions to practice 7. And that's pretty much this handout about rational exponents. Thanks for watching.